dynamics of a given system is very important, but why? For what reason dealing with the dynamics is very crucial or very important? That is a very fundamental question we have to ask ourselves when we are dealing with the dynamics of a given system. So in the engineering science, dynamics is interacting with phenomena of a given system. Let's say the controlling variables are calculated by the dynamics equation. So the controlling variables, one is known by the dynamics of the system. Suppose that we have the high-speed vehicle, or to simplify the concept high-speed vehicle, let's say high-speed train. So the train is having the high-speed train, let's say high-speed train. So train is can be low-speed train, medium speed, and we have high-speed train. So the high-speed train having the speed greater than or equivalent to 160 km/h. They are said to be high-speed trains. When we come to the vehicle dynamics, vehicle is above from 80 km/h is so-called high-speed vehicles or high-speed cars. So how we analyze this speed? The first thing is by dealing with its driving force. Here we have the electrical vehicles and the mechanical vehicles. The electrical vehicles are driven by the electrical motors, and the mechanical vehicles are having with the car engine. And here, in all cases, the driving force is electrical system. We have a different type of electrical drives or electrical motors. So dealing with those electrical motors and with the general dynamics of the vehicle, we can analyze the dynamics once. Once you analyze the dynamics, we have two things. The first thing is to know about the system behavior, and the second thing is to calculate controlling system for the given system and for the given dynamics. So the very important question I have raised in here, dealing with the dynamics in a quantum mechanics, the quantum dynamics analysis is important in engineering science. So dynamics helps you to know about the input, which is very crucial for the control analysis. And dealing with the dynamics is very important to know about what the system looks like. Dynamics, maybe it is a fluid dynamics when you back to the hydraulic system. It's maybe the electrodynamics when you back to the electrical system analysis. We have so many dynamical system analysis strategy, but basically on the vehicle dynamics, we have to understand the speed and with the restriction force. So look at here, understanding the dynamics of the high-speed train is a very crucial for the two cases. The first one is in order to ensure the safety, and the second one is in order to ensure the efficient operation. Why these are important? Safety is the very first concepts when we deal with a given system. After all, one is to design a given system, and we will give that system for the client, for the user. If the user is not okay with our design, it's a bad mess. So we have to consider about our client safety as the top. And the second thing is about operation. Once you design the system, our design system must be operative. Not only on the operation, it must be efficient operation. So the efficient operation strategy is the very fundamental, which is at the top. So every system designed in order to ensure these two things. The first one is for the safety, the second one is the efficient operation, as I mentioned here. So to do that, the analysis factors are like aerodynamics condition, the track condition, and the passenger comfort, what I said. The aerodynamics concept, look at here. Let's say this is a vehicle. Let's say this is the high-speed vehicle. This is a high-speed vehicle. We have forward speed. As I mentioned, the speed is 160 km/h. So suppose the drive is driven by this speed with 160 km/h. There is equal force, and we have an against force because of the external design of the vehicle, because of the environmental condition, because of the topography of the nature. So we have the against force. That against force is so-called the aerodynamics force, which is so-called the aerodynamics effect. So there, according to the Newton's third law, for every action there is equal and opposite reaction. So this is the action force, and we have the reaction force, or the negative against force. So we have to reduce that against force by considering the aerodynamics effect in a given system. So the aerodynamics is one of the first and fundamental factor. The second one is what I mentioned, the track condition or the vehicle condition, the vehicle mechanical design. And the other thing is the passenger's comfort. So this is a vehicle, and inside the vehicle we have a passengers. Inside the vehicle we have a passengers. Those passengers must feel a comfort with this speed, with 160 km/h and above speed. The passenger must feel comfort. So in order to ensure that thing, dealing with the dynamics of a given system, in our scenario, in our case, dealing with the dynamics of the high-speed vehicle is one of the very important and fundamental concepts. So as an engineer, during the design, we have to focus on these two things. The first one is the safety, the second one is the efficient operation. The safety and the operational case must be put at the top of any mechanical and the electromechanical system dynamics of a given system. So having this in mind, and we'll see the detail of how to start the dynamics of a given system. So this is the introductory part. So we'll see the detailed dynamics concept in the next video. So don't forget, like, subscribe, and share. Thank you for your time. If you have any question, comment below. Thank you. Have a nice day. Bye bye.